Go ahead.
All right, you can hear me. Good. Well, I'd like to thank everyone that was able to dial in today. What I'd like to talk about are some of the questions, issues, and considerations when it comes to migration of SCA 222 products over to SCA 4.1 products. When I think about what I'd like to go over today, as much as possible, I would like it to be a discussion of the topic and not necessarily a lecture. I, as most of you probably know, I'm part of the JTNC standards group, and in that capacity, I'm help in terms of the standards development. I am not a developer of 222 products or 4.1 products. So some of you may have interesting insights or different insights that you can bring to the fore in terms of looking at or thinking about this topic. This is really intended to provide that baseline to start that discussion so that the whole industry or group of people have a rough idea about what is related to that whole process of migrating existing products. And if any of you, find things through discussion, or if any of you have items that you think would help to improve this product, please send them to myself, or you can send them to me through Lee, because he has all of my contact information, and I would love to be able to improve this product to make it as accurate as possible. Something that I would also like to mention just prior to going into the meat of the information is that this brief that I'm presenting today is something that is posted up on the JTNC website. There was an announcement that went out a while ago that was announcing the existence of this product. There is also a companion paper that is posted up on the website, and that paper goes into a little bit more depth than the briefing does in terms of some of the specific implementation approaches or techniques that one might use in order to do some of those transition activities. So that's sort of the introductory material. When I think about the concept or the idea of product migration, this brief and this talk will be based on a concept of doing that least amount of effort to migrate from 222 to 4.1. So that would be an end state of saying, instead of having a 222 core framework, now I have a basic bare bones capability 4.1 core framework. It does not try to capture the activities that are related to adding all of those additional features, especially the additional optional features that were introduced as part of the 4.1 standardization process. And it doesn't include all of the additional optimizations that are there. It's just that basic capability of getting from point A to point B. So I will concede that there will be additional effort that would be required beyond the basis to get all of the benefits that are existing within 4.1. The other item is that in laying out some of the comparisons that are pointed out in this brief, there are two important aspects to show. One is isolating the items that have changed in the evolution of the spec, but The other is the inverse of that, of pointing out that there are a lot of requirements. There is a lot of information or constructs within the IDL that has not. So my basic thought, or if I had to give a bottom line position going in, that would be that the migration from 222 to 4.1 is probably going to end up being a smaller hurdle than a few people might think that it would be on first blush. Okay, I've got all of my introductory things out there, so now let's get into some of the specifics. And what I will say is that I might go straight through the entirety of the brief, or we might get through a little bit, and I'll take a time check and see where we are, and we might be able to jump to a later point, because I think that you'll start to see a pattern that develops in terms of what is similar and what is different within the core framework elements. So within, I'm sure that everyone who's listening in is familiar with SCA 222. And within 222, at a high level, there are three basic families of developers. There are people that develop applications. There are teams or organizations that develop devices, and there are organizations that develop infrastructure. Infrastructure being that core of the core framework that's going to provide that common operating environment. So there are three high product lines, or three families of elements that exist within the SCA 222 infrastructure, and each of those are items that would need to be migrated or would need to be evolved to 4.1. And as we go through the brief, we will look at items or look at elements from each of those perspectives. So the first thing that we will hit will be some of those concerns, some of those implications that application developers will need to face, or application developers will address as they're going through their migration activities. So a 222 application or waveform is equivalent to application components within SCA 4.1 speak. Those SCA 222 application components realize the resource interface. One of those items that we stressed as part of the 4.1 rollout activities is one of the, depending on one's perspective, one of the strengths or one of the drawbacks of 222 is that resource interface is a monolithic interface. Monolithic in this case meaning it's something that is composed of not only itself but all of the sub-interfaces below it. So if you are a resource, you're going to realize that LifeCycle interface, and you're going to support port supplier and property set and testable object. When you go to SCA 4.1, the application becomes something that is focused on the component structure. So we have that base component, and base component ends up being the primary element which is going to be included to represent a component of an application. One of those things that we did, so one of the steps that was taken was that resource interface that we talked about in 222 was removed as part of 4.1. You still have the component structure. So think about interface-based 222 and the 4.1 version of the spec that includes the component model. We still have the responsibility from the developer's perspective of having an interface, and that interface is going to be the implementation interface, the one that represents that component. That will need to be built by the development team, by the development organization as part of the product that is going out the door. Something that would make sense, at least in my perspective, would be to create a local common interface representation that could be used or could be leveraged within that implementation. So at the bottom of this screen, you see that interface definition for a base resource, and that base resource is something that inherits from all of the sub interfaces or the optional interfaces that exist in 4.1. Remember, this is a transition approach which is geared towards just getting an apples to apples move. So when I have application components, they will end up being monolithic in nature. They're not going to try to take advantage of the fact that in a 4.1 SCA compliant component, you can utilize that optional composition approach and say, well, my application components don't need to support testable interface, or they don't need to be controllable, or whatever. Those alternatives exist, but this is just an approach, or just trying to characterize that effort or the specific steps that are going to be needed to move that 222 product over to 4.1. So I mentioned that in the 4.1 world, application components are effectively base components. There is another layer of component structure, being that application component and the manageable application component. But in looking at the model representation of that component composition, you'll see that a manageable application component does not bring in any additional interfaces that are outside the scope of what exists within the base component. The other item to mention is that you see that in addition to the regular manageable application components and those base component representations, correspondingly, the application component factory can be developed to provide that same functionality that existed within the 222 4.1. I'm sorry, in the SCA 222 resource factory interface. And I'm sure that everyone knows it, but what I will say is that, just as a reminder, the component user-defined interfaces that I'm talking about, those are not things that exist within the spec. Those are things that one as a developer or one as a development organization is going to have to build or to have to include within their product. So I see that Lee sent out another reminder about questions. So hopefully everyone is with me up to this point. Now we are going to transition into looking at the specific interfaces. So for the testable object interface, well, one thing I'll say is that when we go to start looking at the interfaces, just wanted to mention that this is going to be the model that we'll go through. So we just looked at the model representations of the interface and the components. After looking at those component representations, then we're going to go through the steps at looking at the individual interfaces that are included within that component structure. We'll provide a comparison or look at a comparison of the interfaces. Then we will look at the comparison of the requirements between what was required for an SCA 222 component and what is required for an SCA 4.1 component, the delta of which between 4.1, that's going to really represent the amount of work, the amount of effort that's going to need to be performed from a requirements perspective to make that migration. And then for some of the elements, for some of the items, we will look at or talk about some of the development or design implications of performing that migration. Another thing to mention, again, with people being seasoned designers or developers, which is something that is probably self-evident or obvious, is that you look at just the example that's up on the screen right now, the differences between the 222 testable object and the 4.1 testable interface. It looks simple and straightforward up on the screen that, okay, it was called testable object in 222 and now it's called testable interface. Just throwing out that recognition or that fact that, you know, that naming change is going to result in a number of steps that need to take place. So you would have to go into your product, you would have to make that IDL change. You're going to have to recompile the IDL. Any of the existing code that use the interface names or used whatever was changed within that interface definition is going to need to be updated as well. And if there are any logic things that are associated with that change, it'll have to be accounted for. So none of those items are rocket science or necessarily difficult, but it is work that needs to be done, and it does represent work that needs to be done. Now we look at the property set interfaces. So that was one of those composed interfaces of an SCA 222 resource. You'll note that property set is identical going from 2.222 to 4.1. It was one of the visions that the 4.1 design team made during the construction of the spec. We looked at some of those interfaces that existed as part of 222, and we said, well, these are very prevalent within implementations, or these are really some of the key or critical interfaces that exist. And as a way of trying to minimize the effort that would be required for performing a migration, we made a conscious decision not to switch those names or not to do steps within those interfaces that would raise the cost or would raise the impact without necessarily increasing the benefit to a developer or the benefit to a product. LifeCycle, another one of those interfaces you'll see. The 4.1 LifeCycle is identical to the 222 LifeCycle. So we are able to minimize that, and that is work that would not need to be done as part of the migration. Port supplier, going over to port accessor. This really is the one item or the one element that has a larger change, more of an impact in terms of making that transition from 222 to 4.1. Again, it's not something which is overly difficult in terms of making that migration from one version to another, but there is a conceptual modification and just a philosophical difference between the way that port accessors exist within 4.1. You might say, okay, you made this change, what's the benefit? There are multiple benefits. One was that we were able to define a common construct that existed at the time of port construction or port construction, connection establishment, and disconnection type of activities. So that is one of those things that's going to provide a better foundation or a better baseline for the spec going forward and for the construct going forward. The other reason why it was necessary to go in and make some changes and why we continue to extend those changes through the construct was that what you will see is that when you look at the individual operations that are supported by port and port supplier in 222, when it goes to 4.1, there are changes that are going to be required to multiplex or something similar to that concept within 4.1. 222 had a connect port or a get port. Everything was done in a singular atomic fashion. I have to get one port from this component. Now we're able to use one operation and reduce that chattiness that goes between the framework and the individual components, because we can leverage the operation to do multiple steps within the same call. So connect uses ports is something that has the ability through that underlying connections construct to pass in all of the ports which need to be used from that component, or disconnect all of a component's ports, or to get all of the provides ports that are supplied by that component. So that is a major optimization, and that is one of those elements that allows some of the performance enhancements that exist within the 4.1 specification. The other thing that collapsing port and port supplier into port accessor does for 4.1 is that port concept is now something that is integrated within the core of the component. If you think back or go back to that 222 diagram of the resource interface, you'll note that port was not one of the interfaces that is inherited from a resource. Port was something that was associated with the individual APIs or interfaces that were included by a component. Now making port part of the base of the component, that ends up being something that is a difference, but it's something that will ultimately be a performance enhancer, or it opens the door to performance enhancements going forward. At the implementation side of things, just want to throw out, and this is something that also is covered in a lot more detail in the paper. One can use specific implementation approaches to minimize the impact or minimize the effect of port and port supplier being collapsed into port accessor. And at a high level, the change that would need to be taken would be that instead of being an IDL defined interface, so something that was provided and exposed at the core framework level, that port interface or concept of the port interface is something that could be preserved locally within the 4.1 implementation. So behind the port accessor interface, you can still find a way to use and manage the ports that you defined as part of your 222 implementation. Resource interface. Within resource, you'll see the item that I called out earlier is that the resource interface no longer exists as part of 4.1. Note that there were two new interfaces, the component identifier and controllable interface interfaces that were introduced. And those interfaces are items which are composed from that base component. Or if you want to go down the inheritance chain, those are interfaces which are included as part of that manageable application component. You'll see that those incorporated elements, so the start error, the stop error, the start operation, etc., those things are still there. So as you're making that migration from 222 to 4.1, these are areas where you would go to that 222 implementation. You could do an extraction of the logic that was associated with the start, and you move it from the resource interface over to the controllable interface. This is something I'm not sure of all of the details of the tool implementations that are out there, but I suspect that patterns for things such as this, where there are well-known constructs or well-known entities that exist within a 222 product, that is probably something that can be automated or something that is automated for any tools or commercial items that might be out there to assist in the migration from the one spec version to the other. Also, up on this screen, I will just note that the switch of the interface names, it's not something which is restricted just up to the interface decision or the interface declaration, but also down in locations such as the exceptions where you have those fully qualified names. Those are also elements or items that will need to be updated as part of the migration activities. But again, it's at its core, these are pretty straightforward changes which shouldn't impact items too much. When I look at the application requirements, so from the commonality perspective, an SCA 222 and a 4.1 application component they're all doing the same things. There are capabilities or functions that you know and love, the lifecycle support, the start and stop capability and management. It's still there. So a 4.1 resource does not do anything that's fundamentally different from a 2.2 application component. When do the comparison of the requirements, and these are all rough numbers, but in 2.2 there are about 75 requirements that are allocated to each application component. When you look at the raw count in 4.1, there are about 70 requirements. There was a large activity in the 2.2 to 4.1 development process that tried to look at statements or look at concepts that existed within the 2.2 spec, and if they were things that didn't warrant being preserved as a requirement, we tried to take those out. Us removing those requirements, that's not anything that's going to have an impact on an implementation. So I think that as you are migrating from one version of the spec to another, it's just code that can be preserved. In large part, when requirements were removed from the spec, they were just transitioned over to declarative statements. So instead of saying X shall do this, or the value of X shall be Y, we would just switch that to a declarative statement where X is Y. So at its core, the same functionality will need to occur as part of that product's realization or implementation. It's just something that we determined did not need to be part of the compliance testing. And back to the requirements count in 4.1, while it has 70 nominal requirements, it really turns out to be about 58 requirements, because there are some structural elements or items that no longer need to be viewed as requirements within the, or there are structural requirements that don't explicitly need to be implemented as part of a 4.1 product. Examples of that would be the requirements that say this component shall realize this interface, or this component shall fulfill the requirements of another component. All that those requirements attempt to do is come up with a formal representation of the constructs and the requirements that are going to be applicable to each deployed component in the system. You're never going to explicitly test, verify, validate those requirements as part of a compliance evaluation or a compliance test. So when I funnel out or analyze those 58-ish requirements, I saw there being about 7 unique requirements that are going to be new for a 4.1 component, and none of those, at least in my estimation, of those 7 requirements, there aren't any that are overly complex to implement. There are 3 requirements, or 3 new requirements that are introduced as part of the port restructuring. And again, the specific requirements numbers, those are things that are called out in the companion paper, but it really are those differences that I talked about. It's the change of dealing with atomic entities going to dealing with multiple entities. So you're going from doing things with one port to that list of ports. There are 3 requirements that are associated with that started attribute that was introduced into, which was it, the controllable interface, I believe. The thing after you start or stop an operation, that's just a Boolean variable that reflects the current value as to whether or not the component is started or not started. So even from that conceptual description or discussion, that's something that's not going to be that complex to implement. And there is, believe it or not, there's only one requirement that is associated with the new push model registration that exists within 4.1. And that difference is that now that component needs to register with the component registry, as opposed to registering itself within the naming service. One of the foundational elements that exist in 4.1 is that component type structure. Once the core framework is up and running, each of those components that exist within the system are going to be represented by a component type structure as they are carried through the system. And the shift that occurs or will need to occur within an implementation is where your 222 product may have had individual variables or fields which held and maintain and track values of things, such as the software profile attribute or the object field. Now all of that information has been aggregated within that component type structure, and that component type structure is the thing that's going to be passed through the system, and it's going to be maintained and managed by the manager components. So the component registry, the device manager, the domain manager, the application factory, they all have elements within them that will collect, and then they will have to process through those collections of component types as they do their job. So it's a difference having things maintained within that component type structure. Again, something I will say, and I probably will sound like a broken record on this front, that it's not a difficult change. It's just a matter of making the modification of preserving or keeping that information in a consolidated structure, as opposed to having it in individual fields. And lastly, something to look out for, but it shouldn't be that challenging, is that there were some underlying changes within the AAP. So it would be worth a check of the OE type of operations, those that are provided by primarily the RTOS, just to make sure that those application components are still aligned with the ones that are permitted by the AEP. So that sort of sums up the impact effort implications of that are associated with application migration. Device migration, very similar. So what I am going to do, I am going to zip through devices very quickly. A lot of those things that I pointed out for application components are similar for device components. So you'll see that a device in 222 speak differs from a resource in that it inherits that resource interface, and down at the device level, it adds a number of attributes and operations that are specific to devices as opposed to the application components. The device component in SCA 4.1, we eliminated the application component. I'm sorry, we eliminated the resource interface and the device interface. So now we just have that device component, which uses the base component structure that you heard of, and there are a new collection of interfaces which provide similar functions to the device interface that existed in SCA 222. And once again, it would be good, wise, advisable, pick your favorite word, to construct a common interface such as that base device that exists on this screen that could be used over and over again throughout the implementations of any devices that one might have within their 4.1 product. The device differences, we removed that device interface, and we created those 3 new interfaces within SCA 4.1. You've got the capacity management interface, the device attributes interface, and the administrable interface. And I'm not going to belabor it, but same functionality from a 222 device. It's been transitioned over to those 3 new distinct interfaces within SCA 4.1. So it's largely an exercise just to take that existing functionality from the 222 product and to put it in the right location over in the 4.1 product. There were some attributes such as label that were eliminated, so that no longer exists within the spec. And then there were other attributes which were relocated into that component type structure. So looking up at the screen, software profile is an example of one of those that no longer exists at the interface level, but it's carried around as part of the component type. Similarly, the device structure no longer exists. Now, for the 222 loadable device interface, we have a corresponding loadable interface within 4.1, and we the inheritance of loadable device inheriting from device no longer exists as part of an interface. When that loadable device component is built, that's a point where that user-defined interface, so the component interface that you build, is going to have to include the correct interfaces. But at an end result is that the user-defined interface is going to be equivalent to what was provided as part of a 222 implementation. So it's a matter of doing not only the moving of things, but going through that set of steps that I talked about earlier in terms of the recompilation and accounting for any naming changes that existed as part of the fully qualified names, etc. Executable device. You'll see that where the 222 executable device inherited from a loadable device, when we move over to the 4.1 interface, executable interface, there is no inheritance relationship. That determination as to whether or not your executable device component needs to have loadable behavior, that will be something that will be built and included within, I'll say it again, the user-defined or the product-specific interface. So that is an easy enough change that will be completed as part of the construction or the composition of that new user interface. Where the interface names change, that will have that corresponding set of changes with the fully qualified names that exist within the spec. But again, I will say, you'll probably get tired of me saying it, but it's not a difficult set of changes or modifications that will need to happen to get from point A to point B. One thing that I will call out that is different and will need to be accounted for is that the process ID type, so the one that is identified by step 2, process ID is no longer just a simple long. Now we have constructed that execution ID type structure, which contains not only the process ID, but it allows for the definition of a thread identifier, and it also has fields that will allow us to provide support for the multiprocessor and process co-location capabilities that were introduced in 4.1. If you're doing that straight migration from 222 to 4.1, that is something that can end up being sort of extraneous functionality and not a first priority thing that would need to be performed or accomplished as part of the migration activity. Devices are the same, have the same core functions going across versions, and again, you'll see that there is a reduction of the number of allocated requirements for a 4.1 device component as opposed to a device component that existed within 222. We saw 7 fundamentally new requirements, you'll see that 6 of them show up because of the same elements that we talked about for a resource component. The ports have been restructured, and that started attribute has been introduced. Not difficult changes, not challenging cases. Conceptually, that 7th new requirement is the same as the changes that were required back for application components. The registration approach is different. However, now those device components are registering with the device manager's component registry, as opposed to registering with the application factory's component registry. But it's the same thing. As a byproduct, when you get into the implementation, the one key difference, similar to application components, is that the business of the component-specific information, its identifier, its corresponding object, its supported ports, are all something which are included within that aggregated component type structure, and they are not going to be preserved within the individual fields that existed within that 222 implementation. When look at the loadable devices and executable devices from 222, they don't introduce any fundamentally new requirements that anyone or that a product is going to have to account for. They still have requirements, just not fundamentally new requirements that would need to be accounted for. And there are a few requirements that have some code modifications, but those code modifications are associated with some of those types being different within the 4.1 IDL. So the item that I mentioned before, there's that fact that the process ID construct does not exist in 4.1. It's been replaced with that execution ID type. That's going to need, that change will need to be accounted for within the new implementation. Okay, now we get into, so we've looked at application components, we have looked at device components. My guess is that everyone has sort of gotten the pattern. So if you will permit me, I am going to jump over application and application factory down to the device manager. And again, if anyone has any questions about application manager or application factory, if you bring those up afterwards or send them to myself or through Lee directly, we can address those at that point. The device manager in 222, here is its interface. You'll see that it inherits from the port supplier interface and the property set interface. That, when you look at 4.1, it becomes a little bit different. So there is a distinction that exists because when you look at this relationship, device manager now inherits from base component. And base component not only has property set and port supplier, it provides the potential for things such as the LifeCycle interface or the controllable interface or some of those other things that are included as part of a base component. Since that is additional functionality, when we get, or as we're talking about this basic migration responsibilities, it would not need to be something which would need to be implemented. One can just stay with the vanilla support for port accessor and property set, and not need to go down and incorporate the additional functionality. The other item which is different within 4.1 is we were talking about push model registration and the lack of a naming service existing within the 4.1 spec. Now that 4.1 Device Manager component will have an association with a component registry, and that component registry is something that will need to be developed, and I did not factor that in as part of this effort or part of this comparison. What I will say is that if you look at component registry, that operation that exists within that interface is register component, which is the collapse of the 222 register device and register service operation. So the implementation of a component registry should be pretty similar for someone that already had an implementation of register device and or register service. When look at the specifics of the interface comparison, that device manager interface, it no longer exists. There is going to be a device manager component, which the user, the core framework developer, is going to need to provide. Again, I will go with that same comment or hint from before that it would probably be valuable or useful just to define a generic interface which provides a representation of a device manager or a my device manager that could be used within your implementation. One of the first items that's unique about Device Manager is that you see the file sys operation that exists within 222. It was moved inside of the component type structure, but it was moved into a field within that structure that we have not talked about yet, that being the specialized info field. So specialized info is a variable field in which component type specific information can be held. So the spec has a number of subtypes which are created for the specialized info field that show up in certain situations. File sys is one of those situations which is held, I believe it's in a manager info structure that is going to be used for device manager components. As I had mentioned before, it's the same concept, it's the same information, it's just a matter of holding that information within a different location. When you look at the information that exists within that component identifier or that deployment attributes interface, that stuff that existed within the 222 spec. When we look at the operations that existed within the 222 manager operation, or the 222 device manager interface, you'll see another change, and it's a dramatic looking change. Instead of it being inside of device manager, the shutdown operation is the one operation which ends up being moved over to that new releasable manager interface. Those other operations, so the register device service, unregistered device, unregistered service, those are the operations that I mentioned just a few minutes ago that are going to be moved and integrated off to the component registries. And while I probably should have had a separate slide talking about the component registry, I did not put that inside of this packet. But it won't be that challenging of a migration going from point A to B. And lastly, that get component implementation ID, that operation was removed also, going from 222 to 4.1. There is equivalent information that exists within 4.1 in place of that operation, and that equivalent functionality is just a matter of the some of the properties that were associated with a component type are now held within the component type structure, and those are passed back by the component or the device manager as part of the push model registration. So that will be something which will result in a little bit of effort and time as part of the new implementation of going out and retrieving the information from the domain profile or from the profile information of a device component that's going to be built, and reintegrating that as part of that information which gets passed back to the deployment machinery. And a difference, and this is what I was alluding to when I talked about the device manager component now being a base component. So there are those three interfaces of LifeCycle, controllable interface, and testable interface, which exist within the scope of base component. Those did not have an equivalent entity in SCA 222. So if you were doing a just straight migration, you wouldn't need to implement those. If you wanted to implement those to have a little bit more control over the device manager component, you could, but I did not include that as part of really the elements that are going to be required as part of the migration, because it is optional functionality. The device manager, and similar to the applications and devices, a 4.1 device manager does the same thing as a 222 device manager. And hopefully you saw as we were going through the interfaces that where there were operations or attributes that existed in 222 that still exist in 4.1, they're doing the same thing. When you get down to the requirements count, this is the first place that you will see, oh, even at the level of the effective requirements, there are approximately 70 instead of 56. So you might say, hey, there's new development that needs to exist within within 4.1, and I will touch on that on the next slide. So when we look at the new requirements, there are a number of those that won't need to be implemented because they are associated with those interfaces that don't need to be supported within 4.1. If you ask why I included those within the requirements count, I probably couldn't give you a good answer to that now. But once those requirements are factored out, then the number becomes much more manageable regarding those 8 requirements that one would need to provide an implementation of during the migration activities. A couple of the requirements are just due to text clarifications that we saw, and I call out the specific examples within the paper, I believe, for those requirements. They are elements, they are concepts which it's very likely that your 222 implementation already does it. There just was not a requirement for it. I believe they had declarative statements in the 222 spec, and we added additional text to clarify them as specific requirements to be tested within 4.1. There are 4 new requirements that were added because now we have a component factory, or we have a factory capability on the device side. 222, you remember, only have the ability to have resource factory. So something over on the application side to create factory components. Now there is a component factory that exists and is accessible over on the platform side as well. One caveat that I would put associated with that is that where it was optional to have resource factories in 222, that component factory capability is something that is also optional on both the application side and the platform side. There was one requirement associated with saving allocation properties. So when I went on a little bit about the elimination of the get component implementation ID operation, this new requirement that was added into the 4.1 Device Manager was something which was necessitated to make sure that the core framework still has access to the information that one would have received via that get component implementation ID operation. So getting specific properties that are associated with each implementation that's available for a component. And then there was a new registration error that was added for a device manager, which if one was following normal defensive programming techniques, it would code that would have been implemented anyway. It just now has a requirement that's associated with it. So the item in here, which would be the most expansive or extensive change driven from the requirements, is just would be the fact of supporting the component factory capability. And the other item that I will mention that would also need to be accounted for as part of the implementation of the device manager and the domain manager is that the same things that we talked about regarding that component needing to, the application and device components needing to support the component type structure, that will be required for device and domain managers. And also, the item that is a new wrinkle is that device and domain manager will need to accept items which are coming in that are defined in those user-defined interfaces. So an example of that would be for a device. Say you have developed a device in accordance with your interface of my 1553 device. So that device manager and domain manager are going to have to accept or account for that object that comes in that is of a type, my 1553 device, in a manner it won't do anything to process things at that level of the interface. It will have to navigate down to the fact that my 1553 device can be, in Corba speak, it's something that can be narrowed down to those lower level interfaces that are part of the base component or part of the device component. So I can get to its composite lifecycle interface, or I can get down to its composite testable interface. So that is an item that will require a little bit more work for those core framework components. But you know, going back to my refrain from before, it's not difficult, just work that needs to be done. And the final interface that we'll hit is the domain manager. And from 222, domain manager is something that inherits from the property interface. Now when we get up to 4.1, that domain manager component, similar to the device manager component, is now a base component. So you have a wider breadth of interfaces and capabilities which are accessible for that domain manager component. However, as part of the migration activities, you do not have to provide that functionality, or you're not going to have to support those interfaces. Looking at the specifics of the interfaces, that at the types and exceptions first, there has been a lot of decomposition of the domain manager interface. So we have introduced sub-interfaces for domain installation and event channel registry. So a number of those types have just been moved out of the domain manager level of the interface to those new decomposed interfaces which exist within 4.1. So it's the move, compile, build, make sure you do the text substitutions if you're using fully qualified names that are associated with the locations of those exceptions or those types. Within the attributes, we have also moved a number of those attributes within the component type structure as we talked about before. And in that push towards uniformity, so I talked about the commonization or the standardization of that component type structure. So instead of having those specialized application factory sequence or application sequence types, those are now things that are based on that component type construct. So same information, maybe a little bit of repackaging to get from the 222 representation to the 4.1 representation. Similar to Device Manager, all of the registration operations that were associated with 222, those were all moved out to the component registry. So they are not a core composite part of the domain manager component implementation that you will have to have when you migrate to 4.1. Similarly, if you did not have the implementation of the component registry sitting around already, it would be wise to take some of the lessons learned or the code that was associated with these registration or unregistration operations and migrate that over to the new registered component and unregistered component operations that exist within the component registry interface. And when we look at those specific operations that used to exist at the domain manager level within 4.1, we have also moved those operations to those decomposed interfaces. So we've taken install application. Instead of it being in domain manager, it now is in the domain installation interface. So not a major, not a functional change, not a capability change. There is a difference in terms of where that install application operation exists within that 4.1 product. So you'll need to move, rebuild, et cetera, et cetera. The one small change that exists within 4.1 is that rather than install application being a void, now you'll see that it returns a component type, and that component type is going to be the one that represents the application factory component. If you look at a 222 implementation, that application factory component would have been something that would have been instantiated as part of the install application implementation that you had. It just was not something that was returned from the operation. So that's the minor change of switching the new version to actually return that object that was created. And likewise, it's optional capabilities that were a result of domain manager component being a base component. So it's something that does not need to be implemented. In the similar, a 4.1 domain manager does the same stuff as a 222 domain manager. And based on or as a byproduct of some of those reviews and optimizations that were performed as part of the 4.1 spec, the requirements count went down from around 130 to 112. There were a number of new and different requirements that were introduced as part of 4.1, but again, similar to a device manager component, many of those are not going to need to be implemented because they are associated with the other operations, other capabilities of a base component that surpass what was required of the property set within the 222 implementation. So doing all of that subtraction and math and comparisons, we end up with about 9 new requirements that are going to need to be implemented. And when looking at the requirements, there weren't any that appear to really require a large amount of effort to move from one version to the other. That first one, so the releaser of last resort, that is just something that is introduced to make the domain manager component effectively do a release object call. So it's saying if going down the chain of things, if there was some reason that everything did not get cleaned up as part of the normal termination or shutdown activities, domain manager, try to release it. So that's an easy item to implement. Also, the item that we talked about, the different return value on install operation. That's a new requirement. There are component registration requirements, and actually I think that's something where I just messed up in the slides, because that's the component registration requirements are things that are associated with that component registry and not necessarily with the domain manager component. So I think that's sort of a boo-boo. And there is one new requirement that needs to be provided by a 4.1 implementation that's associated with backwards compatibility, but not necessarily a backwards compatibility thing. And it's just a new exception that needs to be thrown if the core framework's going to notify a consumer that 222 applications aren't handled. So that sums up what I wanted to talk about. Lee, are you out there?
Yeah, just fussing with trying to find the mute button.
Oh, okay.
So I guess at this point, are there any questions? Okay, I'm not seeing any question. I have a question, quick question. Kevin, you said the slides are posted. I heard you mention at least once that there's a mistake in here. Are you going to post an update?
I will post an update eventually. One of the things that I would like to see is if I receive any comments or questions or potential improvements offline of things that might need to go into the brief or go into the paper or should go into the brief or the paper. So I'll probably wait for a while, say between a few weeks or a couple weeks to a month in that time period, and then go through the process of making any updates that I see as being necessary.
Okay. I got a request in the questions window for a link to the slides and more detailed report that you mentioned. So what I can do is I can send that out to everybody who registered for the workshop. Stephanie, I'll work with you to do that in the thank you message that goes out for everybody who attended. We have a question from Anthony DiBernardo asking if you can briefly summarize the changes to XML.
Oh gosh.
Sounds like maybe that's not that's a no.
that is a no. There were a few changes to the XML just for the sake of clarity and classification. So identifying what type of component is actually being processed. There are anchors or elements that exist for components to identify themselves. There are changes in the XML that are associated with the multi-core and process collocation options, and again, those are things that exist within the XML, but they don't need to be leveraged as part of just doing a straight migration. And there were changes in the XML just in terms of supporting basic versioning of a component. So identifying whether or not a component was a 4.1 implementation. Beyond that, I know that there were depending on one's perception of things. So if you were thinking about base 2.2, one of the changes to the XML that was introduced in one of the 2.2.2 extensions was the channel extension to support an enhanced optimization of deployment preferences and techniques. So now that application, that ADD file and the PDD file that were added as part of the extension now exists within the 4.1 XML. And I'm sure there were other changes, but those are the ones that come to mind offhand.
Thanks, Kevin. There's a question. There's a follow-up question. Do you anticipate the XML changes will require extensive rework?
I don't think that they will require too much rework, because one of the things that we tried to do when we were modifying the XML was to make things optional and not mandatory. So where there were changes or enhancements to things, they were typically doors or pathways that one could leverage to get to new functionality or extended functionality. And we tried to stay away from tweaks or modifications to the XML for the mandatory concepts or constructs. Another, just in answering that question, something that would be close to Anthony, if that second question came from him, is that there also were changes in the XML that were associated with the nested application support that was introduced as part of 4.1. But support for nested applications and some of the clarifications for the external interface support. Again, those are additional capabilities that were introduced as part of 4.1 and not part of a straight migration of that bare bones 2.2 component over to 4.1.
Okay. So last question is there a brief summary of benefits obtained by migrating to 4.1 from 2.2.2? I know the Win Forum published a summary of the benefits. I'm wondering, has JTNC published something more official?
We have developed some benefits slide packages and briefs, and one of the things that I do not recall is whether or not we have taken those through the public release process. If we, so I will take an action for myself to check and see if there's anything that has gone through public release, and if we have something, we'll just do a double check to make sure that it's posted up on the JTNC website. If we have not run anything through public release, then we will have the discussion to see if we can do that and get something posted.
Okay. So with that, I think we're out of time. So thank you, Kevin, for taking the trouble to put this together and present it. I know everyone really appreciated it, and thanks to everyone for attending. If there are additional questions, as Kevin said, please send them in. If you send them to me, I'm happy to forward them on, or you can send them to Kevin directly. And with that, I think, Kevin, unless you have any last words, we'll close the webinar.
The only thing, I just would like to repeat what you said, so thank you for everyone who called in and didn't get bored through the hour and a half, and feel free to reach out if you have any questions.
Okay, thanks everyone.